You have to understand certain properties here. That very important rule I had mentioned earlier. Now here we have to understand n of A union B is n of A plus n of B minus n of A intersection B. I told you n of A union B, say for example A is 1, 2, 3, 4, 5. So n of A in this case is 5. B is suppose 4, 5, 6. So n of B is 3. A union B is 1, 2, 3, 4, 5, 6. So n of A union B is 6. A intersection B is nothing but 4 and 5. That is n of A intersection B is 2. So let's see, n of A plus n of B minus n of A intersection B is nothing but 5 plus 3, 8 minus 2, 6, which is the same as n of A union B. Because A union B will have no elements other than those present in A and B. And many of the common elements are written only once. So the number of elements in A union B can never be greater than total of the number of elements in A and B. Right? So in case of disjoint sets, A intersection B is 0. In that case, n of A union B will be just n of A plus n of B. And two very important rules, that the complement of A union B is equal to the intersection of complement of A and B. Say in this case itself, suppose you have U, which is 1, 2, 3, 4, 5, 6 and 7. Right. Now complement A union B is complement. Now complement of A union B is nothing but U minus A union B. So this U minus A union B, which is going to be just 7. So A union B dash is 7. And A dash intersection B dash, A dash intersection B dash, A dash is nothing but 6, 7, intersection 1, 2, 3 and 7. So B dash is going to be U minus B, which is 1, 2, 3, 7. The intersection of these two is nothing but 7. So you see that A union B dash and A dash intersection B dash are both equal. Much the same way, suppose you find A intersection B dash, that is 1, 2, 3, 6 and 7 will be the same as A dash union B dash. So these are certain rules we need to understand. So we see that this is true in this case. Similarly, A intersection B dash is A dash union B dash. So this means first find the union, then compare it with the universal set and find the complement. Here compare sets A and B with the universal set, find the respective complements and then find the common elements in those. Much the same way we have here. Okay, so these are important properties. Okay, now let's see if A has 32 elements, that is n of A is 32, n of B is 42 and n of A union B is 62. You have been asked to find number of elements in A intersection B. Now we know n of A union B is nothing but n of A plus n of B minus n of A intersection B. So which means that this, you take it to the side, n of A intersection B is nothing but n of A, that is 32, n of B is 42, minus A union B 62, that is 74 minus 62, 12. So the number of elements in A intersection B is going to be 12. Right, it is 12. Further, we have very important property, union intersection. Now, suppose we have this kind of a situation That is, there are three sets, A, B, and C. So we have A, B, and C. So this part, including this whole thing, is A intersection B. This part is A intersection C. This part is B intersection C. This part will be A intersection C. And this part is A intersection B intersection C. Now in such case, the union of A, B and C, that means the elements should lie either in A or in B or in C, which means it could lie in this, it could lie in this region, in this, in this, in this, in this, and this. So 3 plus 7 positions A union B union C. That means it has to be somewhere within these three circles. That n of A union B union C is nothing but n of A plus n of B plus n of C. But when you add all the three, many regions keep getting added many times. And to compensate that, we need to subtract this plus n of A intersection B intersection C. Or the same thing can be written as A plus B plus C, add up plus A intersection B plus A intersection C plus B intersection C minus 2 times the number present, because this, in every time you add this, this and this, when you add this A intersection B intersection C gets added 3 times, out of which we need only once. Otherwise there will be overlapping. Hence 2 of those times we subtract A intersection B intersection C. Hence A union B union C is A plus B plus C minus A intersection B minus A intersection C minus B intersection C plus n of A intersection B intersection C, or add up all these ones and subtract 2 times A intersection B intersection C. So thus we have this important properties of union and intersection. Okay, so now we have a 6th example here. It says in a survey of 300 companies, the number of companies using different media are given so and so. Then our newspapers and radio are and television are as follows. N of n is 200. That means the number of newspaper companies, number of radio companies, and number of and the intersection of n of r intersection t is 20, n of n intersection t is 25, n of n intersection r intersection t is 5. Now they are taken 300 companies and 3 types of companies. Now candidates should not overrule the fact there may be companies other than what mentioned, unless it's told considering only these companies. So the best way, since it's such a long list of things, best thing that can be done is put a kind of draw a diagram. It will be easier to represent it. So we have this, we have R, we have T, we can name them. So we have N, we have R, we have T. Now let's list. So N of N is 200. Then N of R is 100. And N of T is 40. And then N of N intersection R, that is this one, is 50. This also includes what is inside. And N of R intersection T is 20, which also includes this part. N of N intersection T is 25, which also includes this. So, and whatever is common for all is this. So first, this total is 300. And you have been asked the number of companies using none of these media, which means a part other than this. So first you need to find this N of N union R union T, which would be the number present in this circle, which is nothing but all these 3. N of N, that is 200, plus N of R, that is 100, plus N of T, that is 40, which is going to be 440, minus N of N intersection R, that is 50, R intersection T 20, and N intersection T 25, that is 70 plus 25, 95, and this total turns out to be how much? 345. 345. But to this we need to add n of n intersection r intersection t. So that's going to be 5. So we have 5, that is plus 5, that is 350. 1 second, 440, 300, 440. So we have 350, which is strange because it's the total itself is 300. Have we made a mistake somewhere? Because this 350 has to be lesser than 300. So somewhere here, 50, 20, 25. Oh, here we have made a mistake here. This is 200. I'm so sorry. It has to be 200. This 200 plus 100 plus t. That is n of n plus n of r plus n of t. That is 440 minus n of n intersection r, n r intersection t, n intersection t. That is 3. So it is going to be 340 minus 95, 245 plus 5. That is 250. So 250 of these companies either use newspaper or radio or television, or some may use even 2. So how many use none of these media? It's going to be 300 minus 250. That is, this part is what we are asking about. So 50, if out of 300 companies, 250 use at least one of these media, 50 use none of these media. So there will be 50 companies which will be using none of these media. So we need to be a little more careful. So we did a mistake over there. We substituted this 200 as 300 and went wrong. So there are 50 such companies. Let's see what we have next. Other properties of union and intersection. We'll be doing more examples of Venn diagram in the following few parts of it. So A intersection A is A, which means a set combined with itself will have, say for example, A is 1, 2, 3. So A intersection A means all the elements common to A and A itself is A. Similarly, A union A is going to be A. Then, so both these A union A, when you combine a set with itself, you get the same set. A intersection P. Now suppose P is a universal set which is 1, 2, 3, 4, because P contains all the elements of A plus something. So A intersection P, if you combine this and this, what is common to both of them is A itself, that is 1, 2, 3. A union P, this and this you combine, you get 1, 2, 3 plus this 4, A union P is P. A intersection P dash. Now A intersection P dash means now complement of a universal set is always a null set. That means you are comparing a universal set with itself and which are the elements present in the universal set and still not present in the universal set. That's what you mean by that. When you say complement of P, it means a set of elements present in the given set as well as not in the union. But when you're taking the universal set itself into account, it's like telling list the elements present in the universal set as well as not present in the universal set, which is going to be no such element. So it's a null set. So what is asked is A intersection P dash. So A intersection P dash means A intersection null set. What is common between a set and a null set is the null set itself. Right? So that's one thing. And A union P dash, if you combine A with a null set, it will be A itself because this is a proper subset of this. Then it's the same as telling A intersection and null set is null set. Both mean the same. Similarly, A union null set is this. Similarly, complement of a null set is universal set. If complement of a universal set is a null set, complement of a null set is a universal set. So remember these things. Apart from that, there are other properties we did, that every set is a subset of itself. A null set is a subset of any set. Right? Okay. And complement of a null set is a universal set. Complement of the universal set is a null set. Union of any set with a null set is the set itself. Intersection of a set and a null set is a null set. Okay. So these are certain properties. Now, for example, let's see how to explore A union A is equal to what? A union A is A. A intersection A, common to A and A is A. A union B dash, remember that thing? A union B dash is always A dash intersection B dash. You just change the U to and then take out that. So it's going to be A dash intersection B dash. Similarly, A intersection B dash would be A dash. You change the intersection to union B dash. So this has been changed and you remove the bracket and you get A dash union B dash. That is this. So we have these as the options. That is A union A is A intersection A is also A union B dash is A dash intersection B dash, and A intersection B dash, that is complement of A intersection B, is A dash union B dash. Yes, it tallies with what we did. Okay. Furthermore, just using these properties, A union E, that is E is a superset, unite a set with its superset. It's like telling unite a set with a universal set. Is a union is going to be E itself. Say, let's take it once more. A is suppose 1, 2 and E is 1. Whenever you have doubts in these kind of things, just put some examples which satisfy the given condition and then find out what is required. Now, what is the union of A and E is 1, 2 and 3. So, it is E itself. What is A intersection E is 1, 2, which is the same as A. E union E. E union E is like union of a set and itself is going to be E itself. A intersection E dash. A intersection E dash is like telling A intersection null set, because complement of a null set is of a superset is going to be a null set, is going to be null set itself. That is this. So whenever a set is given and its superset, if only these two sets are involved, then the superset can be taken to be the universal set. Okay, so hence we have it as this. Okay, now furthermore, you have A intersection E. A intersection E is going to be A itself, as we saw. A union A dash. So A is suppose 1, 2, 3 and E is 1, 2, 3, 4. And A dash is nothing but U minus A, which is this minus this, that is 4. So A union A dash is going to be 1, 2, 3, 4, which is the same as E. So in short, union of a set and its complement is always a universal set. In this case, the superset itself is a universal set. So E. Okay. Then you have A is 1, 2, 3, 5, 7. B is a set of all x squares. So x square means if you take x square, so when x is 1, x square will be 1. When x is 2, x square will be 4. When x is 3, x square is going to be 9. When x is 5, x square is going to be 25. When x is 7, 49. So in this case, n of A is 5 and n of B is also 5. So because whatever elements are present over here, each of them will give a different value for x square, so the number of elements will be the same. Suppose this had 1, 2, minus 2 and 3, 5, 7. You will find that for both 2 and minus 2, you will get the same value in B. So the number of elements in B will become 1 less in such a case. In such a case, NA would be greater than NB. But in this case, each of these elements has a unique value in B, corresponding value. So N of A is equal to N of B. And hence we have it that way. Furthermore, okay, let's take this example. If The universal set E is X such that X is a positive integer less than 25, A is so and so, B and B. Now let's see what are the options. Now here we don't even have to calculate. You have been asked to check these values. Okay, is this true? A intersection B dash, is it equal to A dash union B dash? Remember the trick, we remove the bracket and change it to this and put the dash. Yes, this is true. This is not true because A intersection B dash is not equal to A dash intersection B dash, it will be A dash union B dash. And A dash intersection B dash is definitely not a null set in this particular case. So it's going to be A dash A intersection B dash is A dash union B dash. So that is going to be the right option among these. There is no need to sit and list it all. These are basic rules. You've been asked to check the basic rules. Okay, and so it tallies with what we did. Okay. Now A is PQRS, B is QST, C is MQN. Find C minus A intersection B. Now let's find out what A intersection B is. A intersection B is Q, anything else, and S. So Q, comma, S. T is not present, okay. C minus A intersection B, which is MQN minus Q, comma, S. So it's going to be M and N. So C minus A intersection B is M, comma, N. That is this. Suppose, just out of interest, let's check A intersection B minus C. A intersection B minus C is Q, comma, C minus this, which is going to be S. It will be just S, because we are taking at all the elements present in A intersection B which are not present in C. If it is A intersection B minus C, this is not the requirement of the question. Requirement of this particular question is M, comma, N. So it is M, comma, N. Right? We do have it as M, comma, N. Okay. For any two sets A and B, A intersection A dash union B, where A dash represents the complement of set A. Now let's do this by drawing things. Okay. So since there is a universal set A dash, so there be a box here, which should represent possibly the universal set. A and B are maybe two intersection sets, and A dash union B dash. Now A dash union B dash is nothing but, suppose this is A and this is B. A dash is going to be all that is in the universal set. Okay, all that is in the universal set. But not in A, so it includes even B, part of B. A intersection this of A dash. A intersection A dash union B dash. So A dash, this is A dash, and unite this with B. So it also includes this. So A, this intersection of this part is nothing but this part. So this, all these lines, I'll just explain it once more. We have A, we have B. So first let's see A dash union. So first let's see what is A dash itself. A dash is just this part. Everything in the universal set outside A. This way. Unite this with B. So this already is covering B. Along with that, even this is part of B. So if you unite this with B, it's also this. So that's taken care of only this. Now you have to find the intersection of A and this part. Now this whole thing is A, and what is common for the shaded portion and A is only this part. And this itself is nothing but A intersection B. So it's going to be A intersection B. Candidates can also take examples by listing the numbers, but this would be a little faster. So we have A intersection B. Okay. Now here A is a subset of B. Then which one of the following is true? A is a subset of B. So suppose maybe B is here and this is A. So A intersection B is definitely not B. A intersection B is going to be A. So this is not true. A union B is B. Yes, true. This is true. A intersection B. A intersection B is not A dash. It is A. A intersection B is a null set is not true. So it's going to be A union B is equal to, you unite A with B, you get B itself, right? So A union B is B, right? Okay. From here on we move further to, okay. Let's see what we have here. For any two sets A and B, the set A union B dash is equal to where A, let's do the same job. For two sets, again it involves complement. So let's draw this simple diagram here. We have this representing the universal set U, and you have A here and you have B here, A, B. Now we need to see A union B dash. Now B dash is going to be everything outside B. That is this part, everything outside B. All this is A union, this is B dash. Now you're going to unite A, whatever is present in A, along with what is present in B. So, which would also, A is not just this much, it also involves this. So, it's involving this. So, A union B dash is this. And complement of A union B dash. That is, whatever is present in the universal set but not present in the shaded portion is this part. Now, this part, if you see, is nothing but B minus whatever is present in A. So, it's going to be B minus A. So do it step by step. So start with B dash, which is everything outside B, unite it, and so part of A also comes, but you also have to unite it with U. So it's going to be this. Now once you have shaded, what else is present in the universal set is what is a complement of A union B dash. That is A union B dash, the whole dash. That is the part that you are not shaded. That is this part, which is nothing but B, whatever is present in B but not present in A, that is B minus A. This is our man. Okay, right, you got that right?